This tutorial explains how to retarget a FreeMoCap capture to a Metahuman. With a FreeMoCap Blender output file opened, use the FreeMoCap adapter addon to export the rig and mesh as a FBX file. Select the Unreal Engine export as FBX type, and press the Export FBX button. At the time of recording this tutorial, this FBX export only works with Blender versions lower than 4.0. After the export is completed, the FBX file will be saved in a folder named FBX inside the same recording session folder as the Blender output. Open an Unreal Engine project and import the FBX file. Make sure that there is no skeleton selected, and that the Import Animation option is enabled. Also, be aware that the Blender output default frame rate is 24 frames per second. This could not match your capture frame rate, so it's better to change it in Blender before exporting. Once the import is finished, save the files in the content browser. You can check that the animation was correctly imported by opening it. The movement should be the same as the Blender output. Now we have to create the IK rigs for the FreeMoCap rig and the Metahuman rig. The IK rig element is located in the animation section when right-clicking inside the content browser. Set a name to the FreeMoCap IK rig. Open the IK rig and dock it next to the main window for simplicity. Now select the FreeMoCap mesh in the content browser, and load it in the Preview Skeletal Mesh property in the IK rig by using the arrow icon. Optionally, reduce the bone size display for a clearer bone chain checking. Now, we have to create the bone retarget chains. The idea is to create chains of one or more bones that are similar in both the FreeMoCap and the Metahuman rigs. Select the bones and right-click to add a new chain with a distinctive name. Also, set the retarget root. In this case is the pelvis. Proceed with the rest of the bone chains that were animated and need to be retarget. In most cases, the suggested default name for the chain will be appropriate. So there is no need to write a new name. In the current version of FreeMoCap, the Blender output has bone constraints for the fingers. So fingers bone chains should be added as well if the capture is acceptable and is worth to be considered. As you create the bone chains, they will appear in the panel on the right. You can also use that panel to create, edit or delete bone chains. After creating all the bone chains, save the IK rig. Now create the IK rig of the Metahuman. Set an appropriate name. Open the new IK rig and set the Preview Skeletal Mesh as one related to a Metahuman you have in your project. You might reduce the skeleton bone size for a better view of the bone chains. Now repeat the same process of creating the necessary bone retarget chains and setting the retarget root. In the case of the Metahuman, the retarget root is also the pelvis bone. Note that the FreeMoCap and Metahuman rigs have only some bones named equally. So the important thing is to create a bone chain that is as equal as possible as the bone chain created for the FreeMoCap rig. It is better to use the same names for analogous chains, so later in the Retargeter, the chains will be paired automatically. Make sure to create the same amount of chains, so each chain has a correspondent chain in the other IK rig. After all the necessary bone chains are created, save the IK rig. Now create a new IK Retargeter. The Retargeter element is located in the same section as the IK rig. Set an appropriate name to the Retargeter. Double-click the Retargeter to open it. A menu will appear to select the IK rig that is the source of the retarget, in this case that corresponds to the FreeMoCap rig. After selecting the source IK rig, you will have to select the target IK rig. That corresponds to the Metahuman IK rig. Once the IK Retargeter is opened, you can optionally reduce the display size of the bones to better match the rest pose of both IK rigs. You can adjust the size of the Metahuman preview mesh, to make easier the matching the pose of both meshes. Now, you have to adjust the Metahuman pose so it matches the T-pose of the FreeMoCap mesh. First select the Edit mode. One way to edit the pose is to select each bone and rotate it until it matches the rotation of the FreeMoCap rig bone. Another way to edit the rest pose of the Metahuman rig, is to import an already saved pose asset. In case you don't have a saved T-pose asset, you will have to set the pose by manually rotating the bones as described earlier. Make sure you save the pose asset in case you need it in a different retargeting. Once the rig poses match as best as possible, you can increase the target mesh offset so the meshes don't overlap. Also, you can check again the bone chains and the chain mapping on the left and right panel respectively. Now, go to the Asset Browser tab and double-click the animation to check the retargeting. In case some bone chains are not retarget correctly, you can adjust the rest pose again to improve the retargeting. When the retargeting looks correctly, click on the Export Selected Animations button. You can select the folder where to save the retarget animation and add a prefix or a suffix to the file name. Now, to check the final animation on a Metahuman, create a new level sequence from the Cinematics section. Open the level sequence and add the Metahuman to the tracking actors. Close and open the level sequence if you are not seeing the timeline. Delete the control rig in the actor's body section. Now add the animation to the body part of the actor. Also, add the FreeMoCap skeletal mesh to the viewport. Now add the FreeMoCap mesh to the level sequence timeline. Add the animation to the mesh in the body section. Reopen the level sequence in case you can't see the animation tracks. And that's it. You have retargeted the FreeMoCap motion capture into a Metahuman rig. As long as the FreeMoCap Blender output rig does not change, you can reuse the IK Retargeter. So next time you just import the FBX file, open the Retargeter, check the animation is correct and export it to be used with a Metahuman. That concludes the tutorial. Thanks for watching.